Okay. So welcome back. Happy Wednesday. It's in here.
Thank you.
Okay. So today is October the 12th. We are covering our second of 2 days on the chain rule. Remember, we had said last class that the chain rule is the most important derivative rule that you will ever see in your entire lives. Also, steel drum and pipeline were assigned last class. I know some people are asking questions about it, which means some people have started it, which is awesome. So see if you can follow that recommended timeline on the first page of those two projects. Questions on the calendar? Okay, then let's jump in here on page 8 to our second day of chain rule. Daily summary. Today, we expand our ability to use the chain rule to differentiate functions defined numerically and compositions of more than 2 functions. We also learned that dogs do calculus. Start with number 1 here. Sometimes we have to apply the chain rule repeatedly. In the process of evaluating the derivative of the stuff, we might have to use the chain rule again. So let's see a couple of examples of that in number 2. Let's find the derivative of the following. So part A, or the first one, I guess, is just y equals e to the sine of 2x minus 4 cubed. And we're going to find the derivative of that entire thing. So this is by far the most complicated thing we have taken a derivative of yet this semester. But we just have to follow the chain rule and the pieces will come out. Okay, let's give this a shot. dy dx equals. So I see e, I see sine, and I see a cubed. And we have to figure out what is the overarching rule that we have to follow here. Which one is this thing predominantly? Is this an e or a sine or a cubed? This is an e. This is e to a bunch of stuff. Everyone agree? First and foremost, it's e to a bunch of stuff. So we need a rule for the derivative of e to the x. And this is a rule that we'll see more formally in an upcoming class. But last class, I just gave it to you. I said the derivative of e to the x is e to the x. So the derivative of e to the stuff is e to the stuff times derivative of the stuff. So the first thing we do is copy e to all of that stuff. And then we multiply by the derivative of the stuff. And the stuff is this entire power up here. So let's multiply by the derivative of that stuff. So the thing in yellow is sine of some stuff. Agree? I'm not bothered by the fact that it's some things cubed up there. That is first and foremost sine of some stuff. So I need a rule for the derivative of sine of some stuff. Again, we don't have it yet officially, but I told you at last class that the derivative of sine of x was cosine of x. And so the derivative of sine of stuff is cosine of stuff times the derivative of the stuff. So cosine of the stuff times the derivative of stuff. What's the stuff now? Is this 2x minus 4 cubed? That is what I want the derivative of now. That's what we're waiting for. And primarily, to take the derivative of 2x minus 4 cubed, I need to think of the power rule. That is some stuff to the third power. And so what's the derivative of stuff to the third? 3 2x minus 4, right? Copy the stuff. New power is squared. And then times the derivative of the stuff. And we'll highlight one last thing here. The new stuff is just the 2x minus 4. What's the derivative of that stuff? 2. And that's the answer. Yeah. So we can see that derivatives tend to expand. They're kind of like those old-timey telescopes, right? Like it's really small in the beginning and then just gets bigger, bigger, bigger. But the fact is, all of, like it might feel like we did like 3 different derivatives. We didn't. We did 1 derivative, right? We took the derivative of something really complicated. And in taking the derivative of that something really complicated, we had to know what the derivative of sine of 2x minus 4 cubed is. And all of this is what we came up with. That is a single derivative of the stuff. The derivative of sine of 2x minus 4 cubed is what I've underlined here. It was just the derivative of the stuff one time, but it happened that that stuff involved in itself two different chain rules. We had three chain rules here, but it was just one derivative. And so you can see it's going to be more and more challenging for us to really just keep track of what's the stuff that we are trying to take a derivative of now. All right, questions on that one? Okay, number 3. We're going to leave it like that, although to be honest, really the only natural simplifying thing that I see is smushing the 3 and the 2 together, putting a 6 in the very front. I don't see anything else natural to do here. Okay, number 3. Given the table below, find the indicated derivative at x equals 1 if possible. Write CBD if the derivative cannot be determined. So I've got this table of values. When x is 1 in the first row, I've got the value of f of 1 and f prime of 1 and g of 1 and g prime of 1. And in the bottom row, I've got the same thing, but when x is negative 2. And I'm trying to find the derivative of f of x, the whole thing squared, minus 3 times g of x squared. And so we can't use any of the nice rules that we're developing for the derivatives of e's and sines and powers. We just have to understand the chain rule really well to do this kind of problem here, because all we have is a couple of values in a table. So here's the basic idea. This first one right here, I see this as some stuff squared. You guys see that? That is some stuff squared. What's the stuff called in this part? F of x, right? It's just some function squared. I don't know what the function is. I've got precious little information about f in that table, but that is some stuff squared. And I know how to take the derivative of some stuff squared. On the other side of things, this piece here, I see g of some stuff. What's the stuff in that case? X squared. We see the difference? Like that squared is in a radically different spot in the two places. On the one hand, the first case, it's squaring the whole function, all of the stuff. On the other hand, it's inside the function. It's only squaring the x. And how we handle these is really different. So let's see if we can do it. So this thing here equals. So let's do the derivative rule for some stuff squared. What's the derivative? Use the word stuff in your answer here. What's the derivative of stuff squared? 2 comes down. Copy the stuff. New power is 1 times derivative of the stuff. Yes? That's how we do stuff squared. So let's try it. 2 comes down. We're copying the stuff. What's the stuff in this case? F of x. The new power is a 1. I'm not going to put it because it might look like a prime. Times the derivative of the stuff. What's the stuff? Is f. So times the derivative of the stuff times f prime of x. That's it. That's the derivative of f of x, the whole thing squared. 2 comes down, copy the stuff, times the derivative of the stuff. I know as a math teacher, I should probably feel funny using the word stuff so often, but I honestly, this is how I think of it. And I don't think of it in terms of symbols and f's and g's and primes. I just think of stuff. Let's do the next part. I see a subtraction sign. We'll do this guy in another color. Okay, we see the subtraction sign. 3. What happens to that 3 when I take a derivative? Stay or go? Stays, right? That's a 3 times. So I'm copying the 3. Okay, now we have g of some stuff. G of some stuff. I need to know the derivative for g of some stuff. I will remind you. What will I remind you of? I'm going to write this here. We saw this last class. You can write it if you want. Unfortunately, the letter choice that we've got in this problem is kind of strange for what we're about to do. But I'm going to write down the rule that we had for this. The rule that we had for this was f prime of g of x times g prime of x. This is something that we looked at last class. I said we're going to use it next class. This is the time when we're going to use it. The problem is I need to change the letters here. I need my outer function to be g because I see g of some stuff. So I'm going to rewrite this guy with the letters reversed. And you guys are going to tell me what the formula should be. What's the first thing we're writing here? G prime of f of x times f prime of x. Yes? Just same letters reversed. So just change the roles of the letters. Okay. And so in the case of what we're interested in here, we're looking for the derivative of g of some stuff. Well, that's exactly what we've got here. This is g of some stuff. So in our case, the stuff is what? Is x squared. That's the stuff. That's the f of x function, okay? So every place I see f of x over here, I'm thinking x squared. That's what the formula is. So let's give this a shot. The formula here says g prime. Okay, well, I don't know what g is, so I just have to literally write g prime of, and then it says f of x. What is f of x? X squared. That's what goes right there. Times, and then it says f prime of x. Well, what is the derivative of that yellow function to x? That's the chain rule. I haven't used the table yet, but trust me, the hard work is done. We're going to use the table. It will be very easy from here. But that's the tricky part that we've gotten there. And so this kind of problem really tests you. So like I mentioned that I took AP Calculus as a senior in high school, and I was really good at taking the chain rule for examples like number 2 that we just did with the e. Like I could do e to the sine of whatever, but I did not understand the chain rule well enough at that point to do this kind of problem. I could do it for specific functions. You give me specific functions like a number 2, I could handle it, but I couldn't handle this level of abstraction. So we're pushing you guys to understand this more complicated level here. All right, let's see if we can then do the derivative evaluated at 1. So I'm going to just sort of start over. I don't want to copy the whole thing. But you guys remember this was our symbol for take the derivative and evaluate it at 1. So all we're doing is changing all the x's in that previous line to 1s. So 2 times f of 1 times f prime of 1 minus 3 times g prime of 1 squared times 2 times 1. Okay, that's all we have to do is grab all these numbers here. 2 times f of 1 from the table. F of 1 is how much? Is a 1, right? That guy. 1 times f prime of 1 is 3 minus 3 times g prime of 1 squared. Fortunately, 1 squared is 1, which is in the table. If it weren't, we couldn't do it. So we got g prime of 1 is negative 1 times 2 times 1. So that's our calculation. Is that 12? Yes? Is it not 12? 6, and then there's a 6, and then that becomes a plus 6 over here. So subtract. Yeah. Okay, so like I said, I could not handle this when I was taking calculus. With some practice, you guys are going to be able to handle this. Okay, questions on that?
Would you have the same answer?
If we used what, negative 2? So instead of x equals 1, if we had done x equals 2, well, so the bottom row has completely different numbers. Yeah. So we get a different answer in that case. Okay. Levi. Other questions? All right, so the activities start on the next page. We've got a sort of standard collection of activities here. The bottom one on this page is going to be quite similar to the one that we just did. But then on the next page starts a collection of problems about a dog trying to go catch a ball in the ocean. So you're going to work through the first page, and then you'll have this collection of problems all related to each other. Raise a flag if I can help.